Let's look at this first example. I'm going to start by getting my equation in standard form. So it's ax squared plus bx plus c. I need to move this 8 over, though, to set my equation equal to 0. So this becomes negative 7x squared plus 7x plus 9 equals 0. Then I'm going to label my a, my b, and my c. A here is negative 7, B is positive 7, C is positive 9. Now I'm going to set up my equation. So x is equal to negative b plus or minus the square root. B squared minus 4ac, all over 2a. That's why we do the song. So we can memorize the formula and plug it in really quick. But I'm going to plug in my values. So this is x is equal to negative 7 plus or minus the square root. 7 squared minus 4 times negative 7 times positive 9 over 2 times negative 7. So I'm going to do my first round of multiplying. This is negative 7 plus or minus the square root. 49, I'm going to multiply. Negative 4 times negative 7 times 9 is 252 over 2 times negative 7, which is negative 14. Now I'm going to add underneath my square root. I get negative 7 plus or minus 301 over negative 14. So what we have here are two separate equations. So we have a funky square root. You would simplify that if you could. 301 actually is a prime number. It doesn't simplify. So we're just going to leave it 301. But this tells you that your zeros are at negative 7 plus the square root of 301 over negative 14, and negative 7 minus the square root of 301 over negative 14. Now looking here, we can simplify. So you could keep it like this, or we could simplify our answers because negative 7 divided by negative 4 is 2. It'd be the same as saying 2 plus the square root of 301 over negative 14, or 2 minus So obviously these all give you some like kind of funky answers, but the reason is like when you have a parabola, you're not always going to land perfectly on a number. And actually this, because it's a formula, is my go-to. I actually don't normally factor when I'm solving for zeros. I normally go straight to the quadratic formula because you can plug in all the problems from yesterday and get the whole number answers. But this formula can be used when our numbers are whole numbers, when they're funky, weird numbers like you see below, when they're imaginary. All of those things can be solved using this formula. So you're actually going to see me use this formula a lot from here on out whenever we're solving for zeros, because I like, as crazy as a formula it is, I think it's the most straightforward way to do it. And what you can actually do to check your work, or like when you're actually graphing, obviously you're not going to graph -7 plus the square root of 301 over 14. You would plug that in and figure out approximately where that was. When you do that, you get x at approximately 0.74. Sorry, negative 0.74. and positive 1.74. So on your graph, that's where your points would go when you were graphing this. Now you're going to try one, plug it in, go one step at a time to solve for the answer.